All right, hey guys, welcome back. It's 11.2 time, 11.2. I'm hoping you're following. I know this is not easy. And what I'll do is I'll be doing the problems that you don't know how to do. I'll have a whiteboard at home and we'll work them out together. But today we're gonna do 11.2, which is proving triangles. All right, proving triangles. Okay, so for today's lesson, we're going to talk about proving triangles, and there's three ways to prove triangles are similar. If you can remember, when we talked about proving triangles were congruent, let's see. Genesis, can you answer this for me out loud? I'm sure everybody else will be answering it as well. But there's three ways that we can prove triangles were congruent. All right, we're congruent. Side, angle, side. Angle, side, angle, 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 side, and side, side, side. So those are the four ways. Now, all of those said that the angles and the sides must be congruent. Now, in this lesson, we're going to start talking about similarity. Now, remember, what does similarity do? Similarity does something specific. Similarity does what we would call, it preserves the shape. So when we talk about congruency of this or similarity of these things, the one thing we will always say is that the angles, because the angles determine the shape of a triangle. The angles determine the shape of a triangle. Remember that. The angles determine the shape of a triangle. So therefore, when we talk about that, when we talk here and we talk about similarity, you're going to need to remember that that's the most important thing, is that the angle is preserved. And that's going to stay the same. So when I say similarity of triangles, there's three methods to do that, okay? 1, 2, and 3. 3 sets. Now remember, we're still dealing with triangles, which deal with sides and angles. Sides and angles. So, here's the key. When we have two triangles, X, Y, Z, A, B, C. Now, how would you think we would go about proving that these triangles are going to be similar? What must be true? So the first thing is, one is angle, angle. The angles okay, so it's AA, they must be congruent. Two angles must be congruent. So if Y and B are congruent, and A and X are congruent, I have two triangles that are going to be similar. And the reason they are is because their shape is similar now. Why? How come? Well, what about the third angle? The third angle, Sarah, why is the third angle gonna be, what do we know about that third angle? Because we studied triangles, and in studying triangles, we learned what, Sarah? Yeah, we learned that two angles, okay, two angles are congruent, then the third was congruent. So therefore, we know these two shapes are going to be exactly equal. So if we have two angles being congruent, then the third we know is congruent as well. Now, so that's the first one. The second one is this, is that if all three sides are similar. In other words, all three sides are similar. So when we talk about these three ways to prove that are similar, the angles have to be what? Congruent, but the sides have to be what? Similar. So they don't have to be equal, they just have to be similar. So the little symbol for similar is just the squiggly line. They have to be similar. In other words, they have to be what we would call proportional. The sides have to be proportional. It's not about the angles now because we don't know. We just need to know that the sides being proportional, all three sets of sides being proportional, will make that true. And the third and final one is going to be side, angle, side. So, what do we need to know about our sides? The sides have to be what? Sides have to be what? Anthony, wake up. Oh, yeah. All right, Anthony, go ahead and give me the answer. Yes, sides are going to have to be what? Similar. And the angle has to be what? Congruent. Good. Now, do you think the order of these letters is important? The answer is yes. Why? Because you can't have, it can't be two different angles. It has to be the same angle that's contained between the two sides. All right? Those are important. Any questions on these three? So if the proportions of the sides are equal in all three of them, then you have side, side, side similarity. All right? Any questions on that? So, why is this important? It is important because what we're going to learn in this section is that you compare small triangles to big triangles, small angles to the same angle on the other side. Now remember, I gave you this really challenge of that nobody would get it wrong. But yeah, there were still a lot of you that missed that on the test, that the angle wasn't right. Because I'm not sure why, but I think some of it is because you didn't think through the problems specifically. So let's do this problem together. It says this: Mr. Ward needs to ensure that a diseased tree in the front yard will not fall on his neighbor's house when he removes it. Using similar triangles, find the height of the tree if it casts a shadow of 45 when Mr. Ward, who is 6 feet tall, casts a shadow that is 4. So let's draw this. And then one of our assignments for this week is going to be to go outside and measure some trees. And we're going to have some fun with that. I'll teach you a little bit of that. Probably not here in the office, in the building, but I'll teach it outside of it. So here's what we have. So remember the tree, and you know my great artist skills. There's my tree, and it casts a shadow. All right. Okay. A shadow that is 45 feet. Okay? And then we have a person, Mr. Ward, right? Once again, my artistic ability, same height. He's 6 feet tall, and he cast a shadow right here that is 4 feet. So looking at our drawing, and I'll draw my two different triangles here for you. So we have this triangle here. And this is 45 feet. And this triangle here, see this triangle, 4 feet by 6 feet. We're looking for this height. So how do we solve? Okay, so how do we solve? We set up our proportions from last section. So it's going to be x over 45. So the x is the height. So what's the height of Mr. Ward? 6 feet. What's the shadow? 4 feet. Cross multiply. Now remember, you can always cross cancel top and bottom, right? So that's going to be a 3 and a 2. Makes our math work a little bit easier. 3 times 45 is 135. And 2x. Divide by 2, x equals 67.5. 67.5. Does that make sense to everybody? So that's what you're going to be doing using your information that has been taught you in this lesson. So that's 11.2. If you have any questions, please feel free to Zoom me. I'll answer any questions you have. Thanks.